With maths, I've always told you again and again, you must be at ease, all right? Relaxed, cool, calm, feel so happy, don't have a sour look, smile. All right, maths with Kumar is not painful, it's beautiful, all right? Let's look at this sum. We have sine theta is 3 over 5. Now they've asked us a whole lot of things. And if you don't have enough information, you're going to go boop. But you know it, and I know you know. And how do you do that? Let's check it out together. When they say sine theta is 3 over 5, what does that mean? Well, draw your angle. That's your theta. It's opposite over the hypotenuse, right? So your adjacent by Pythagoras theorem is 5 squared minus 3 squared. You get 25 degree 9 is 16. And the square root of that will give you a 4. So this is what you found out. Next thing, they said, oi, what is tangent theta? Tangent, look at that. Are you afraid? Tangent theta. Hey you, tangent is 3 over 4. So that's no fear. Tangent theta is equal to 3 over 4. Next part, they said, oi, cos theta plus sine theta. What does that mean? Oh, they just want you to work it out. Cos theta plus sine theta. What is cos theta? Adjacent over the hypotenuse. And where's your adjacent? Adjacent is always beside you. So make sure, even if you are cockeyed, look right, all right? Now you look at cos theta, it's 4 over 5. And if you look at sine theta, it's 3 over 5. When you add them up, you get a 7 over 5. With very little pain. Alright, you've got that beautiful answer. Now let's look at C. What is C? They said, hey, cos theta minus sine theta. Now there must be a trick in me giving you the sum because I want to see some relationship. And I'll show you more as I go along. Cos theta minus sine theta. Your cos theta is 4 over 5. And your sine theta is 3 over 5. When you take away, you've got a 1/5. Yeah. And the third part, what is cos squared theta minus sine squared theta? Now if you look at cos squared theta minus sine squared theta, I just want to show you two methods of getting the answer. Well, cos squared is 4 over 5 square root. Alright, this one method, 4 over 5 squared. What is sine squared theta? 3 over 5 sine theta, and you square it. So you've got 16 over 25 minus 9 over 25. What is 16 minus 9, my dear friends? 7 over 25. Now that's your answer. Yep. Now, but you remember your rules in algebra. Alright, so let's look at method 2. For this sum, this is method 1. What is method 2? We say, hey, alright, cos squared theta minus sine squared theta is none other than cos theta plus sine theta. Right? Remember that? What formula? Remember this one? Is cos theta minus sine theta. Alright? So it's just a squared minus b squared. You get an a plus b, a minus b. I don't like the sum going into this problem because I've got another sum right here. And that's what we call intruders coming into the sum. So I'm going to rewrite that again for you. Well, this means cos theta plus sine theta times multiply with, if I write it here, cos theta minus sine theta. So what is this value going to be? You worked it out. Cos theta plus sine theta My dear friends, look at this. What was your answer? 7/5. Yeah. And you also work this out. Cos theta minus sine theta. Remember this one? What was your answer? 1/5. Yes. So you're going to multiply with 1/5. Alright? So when you multiply them, 7 times 1 is 7. 5 times 5 is 25. Hey, look at it. If there's one jam, another door opens. You look at it. If you can't do this way, you can do that way. There are many ways of doing sums, many alternative ways. So take note of it. Now, if you look at E, what is cos squared plus sine squared? I know you know it. Alright? Shh. Let's do it by this sum and see if that matches the answer that you have preconceived. Now, cos squared theta plus sine squared theta. What is your cos squared theta? 4/5. You square it up. Alright, you get 16/25. And what's your sine squared theta? Sine theta is 3/5. You square it up. You get 9/25. My dear, 16/25 plus 9/25 will give us 25/25 or 1. Alright? So you see the fundamentals that you know, you feel very confident that you're going to get it right because you know cos squared plus sine squared is 1 for the same angle. Okay? Alright, now we have question 2. Look at it, it's a little bit more complex, a little bit with the diagram which I've put in this dotted line, which is actually a 90-degree triangle. But this triangle as such is an obtuse angle triangle. It's obtuse. And we need to get a series of angles. Don't panic. Breathe in, breathe out. Alright? Breathe in, breathe out. First, we got to find out what is x and what is y. Okay? Now you look at this, x and y. Just not so possible. But if you looked at this triangle here, I'm going to draw it out as a 90-degree triangle. I said, hey you're 2 and you're root A. And you, I'm going to call you as a big X. And you are the theta. Later we look at this big triangle, the 90 degrees triangle. And you can see that x squared plus 2 squared equals to square root 8 squared. Pythagoras is very friendly. Alright, we find it so useful. And what do we get from there? We get your x squared to be, this is 8, right? This is 4. Bring it over, minus 4. So your x squared is a 4. And your big X, square root of it, will be a 2. A length cannot be, when you square root something, we always tell you, it is positive and negative. But can length be negative? No way unless you're underground. Right? So no way. So remember that. You reject the minus and take the plus. Great. So you said whole length, you are 2. And what else did they tell us in this diagram? They inserted this. Okay? They inserted this, and this x, big X here, is made up of x, and here's 1. So this big X is made up of x plus 1. And if your x is 2, so what is your little x gonna be? 1. Yeah. So your little x is gonna be 1. Next, we said, okay, your 1. Put it down. And this is your y. What is y? Isn't this a right angle triangle? Yeah. So how do you get that y? We can use a Pythagoras theorem. Yes, y squared is 2 squared plus 1 squared. 4 plus 1 is 5. So your y will be a square root 5. Great, you got that. Now, we need now to find out a few of these angles. Sine theta, tangent theta, cos theta. Now, is that a problem? What is sine theta? We look at a right angle triangle. And what does it tell us? It's 2 over square root 8. Alright? So your sine theta is equal to 2 over square root 8. Now your square root 8, if you wish to simplify it, is square root 4 square root 2, right, my dear? Square root 4 is a 2. 2 and a 2, you chop off, chop, chop. You get 1 over root 2. They call this presentation crude. Alright? When you have a square root at the bottom, it's called crude, impolite in maths. So you want to remove that square root 2 at the bottom. What do? We multiply up and down by square root 2. So what we get is a root 2, and root 2 times root 2 is a 2. This is a far better answer than this. They're all right. They're all perfectly correct, but this is a better form than this. And if you want a distinction, you do not want anyone to penalize you, then write it this way, alright? Next, what is cos theta? Well, cos theta, alright, will be, look at it, cos theta adjacent over the hypotenuse. And we know that this is 1 and 1, this whole thing is 2. So it's 2 over root 8. Now it looks like they are both, if this is 2 and this is 2, this is an isosceles triangle. No doubt the triangle, my diagram doesn't show it. And usually these are tricks that goes on. They don't have to look alike, but when they are alike, because they don't want to give you that many clues. So as I said again, we expressed it earlier on. Remove that. We've got a root 2 over 2. Great. And what is your tangent theta? Well, your tangent theta will be, yes, opposite over adjacent. Your opposite is a 2 over 2, and that's a 1. So this is actually a 45-degree triangle. Your theta is 45 degrees. Got it? Okay, now they want the story of gamma. Well, where is gamma? Look at that. Hey, you. Alright, what is sine gamma? Well, sine gamma, look, I think you've become an expert in it. You get a 2 over your y. Your y is a square root 5. Write it this way. So your sine gamma is 2 over square root 5. As I told you, this is crude. Multiply up and down by root 5. You get a 2 root 5. A root 5 and a root 5 will be a 5. Great. And then they asked you, we've done this, and they want 180 minus gamma. Right, is that going to worry you? Sine 180 minus gamma, which is this angle, my dear friends. 180 minus gamma, adjacent angles on a straight line. But you know a very powerful thing. What is it? We knew if this is gamma, this is 180 minus gamma, 180 plus gamma, 360 minus gamma. They all share the same answers, don't you remember that? So your sine 180 minus gamma, whether it's positive or negative, it's lying in the sine quadrant. So this will be the same, and that's the answer. Yeah. And if we look at the next part, that's done. Cos 180 minus gamma. Look at that. Your cos 180 minus gamma is, look at cos gamma. What is cos gamma? 1 over root 5, right? Your cos gamma is actually equal to adjacent over the hypotenuse. And because, as I said, 180 minus gamma is lying in that quadrant, is it friendly to cosine? No, it's friendly to sine. Remember, CAST. This quadrant is only friendly to sine, cosine, and minus. So your cos 180 minus gamma is the same answer as that, but with a negative. But as I told you, we don't like root 5 at the bottom. Multiply by root 5, you get a root 5 over 5, and this is a negative answer. Now we look at tangent. Tangent, that's done. Tangent 180 minus gamma. Tangent, same story, my dear friend. Look at gamma. What is tangent gamma? 2 over 1. Alright, so that's part 5 and that's part 7. We look at tangent 180 minus gamma. You know tangent gamma is 2 over 1. And that's 180 minus gamma. Ooh, unfriendly to tangent. What does it become? It's a minus 2. Alright, we've got it, right? So what we did, so easily, this whole sum unfolds before you because you're connecting the fundamentals of trigonometry as you get along. Alright, we'll have more.